Welcome to part 2 of section 3.5, where we are going to be deriving a derivative. So we want to prove that the derivative of cotangent of x is negative cosecant squared of x. This is just a rule that we need to know, but I want to prove why it works. And you can do the same thing with the other four that aren't sine and cosine. So you can do the same thing with tangent, cosecant, and secant to prove. The building blocks are the derivatives of sine and cosine. Those are the like OG trig functions that you need to know. All right, so the first thing that we're going to do is just rewrite cotangent. So I'm just going to rewrite cotangent of x using those building blocks. The cotangent is the reciprocal of tangent, so it's flipping tangent. So tangent is sine over cosine, so therefore cotangent is the cosine of x divided by the sine of x. Now we see that the cotangent is a quotient or a fraction. So we are going to use the quotient rule in order to find the derivative. So what I'm going to do is take the derivative of cosine over sine, because that is what cotangent equals. All right, using the quotient rule means that I'm going to do low d high minus high d low, all divided by low squared. So low, which is the denominator, times d high, which is the derivative of the numerator. So the derivative of cosine is negative sine, minus high, d low is the derivative of the denominator. The derivative of sine is cosine, all over low squared. So sine times sine, which is sine squared of x. In the numerator, we can do some cleaning up. Sine times negative sine is negative sine squared of x. And then we'll have minus cosine squared of x all over sine squared. Now the biggest thing that we have to remember, well, let's do one thing first. The next thing that I want to do is factor out this -1 in the numerator. And so then we'll be left with sine squared x plus cosine squared of x. If you remember back from your trigonometry days, this is the most famous identity in trigonometry, which is that sine squared plus cosine squared equals 1. And we can actually derive the other two trig identities from this one by dividing, but this is the main one. So sine squared plus cosine squared equals 1. So we have -1 times 1, which is just -1 in our numerator. So moving over here, we'll have -1 over sine squared. The reciprocal of sine is cosecant, so the reciprocal of sine squared would be cosecant squared, and it's negative. So rewriting, this is negative cosecant squared of x. We have just proved that rule for cotangent. And again, you can similarly do this with the other four non-OG trig functions. We could do it for sine and cosine. It's a slightly different process, but the other four can all be rewritten in terms of sine and cosine, which are like the building blocks of trig, as I've said. So if this is the part that confused you, I recommend that you go back to our early videos in the prerequisites for calculus when we talked about like the building blocks for the unit circle. If this is the part that confused you, this is not something we explicitly covered this year. This is called a trig identity. And if need be, I can make a video covering those if we feel like we're struggling with them. I will see. The rest of it really is just simplification. So this is another simplifying and understanding how to define. It's kind of like going from here to here and from here to here, understanding that cosecant is the reciprocal of sine. And something that I remember having to learn just from doing these types of problems was that even if something's squared, it still follows the same pattern. So 1 over sine is cosecant, but 1 over sine squared is just cosecant squared. All right, so we have successfully proved the derivative rule for cotangent using the building blocks of trig and some cool trig identity magic.